My name is Erik Maziarz. I'm coming from AGCO Corporation. It's somewhat of a generic sounding name, but it's an agriculture company. Build different kind of agriculture farm machinery, tractors, combines, implements, dairy devices also, feeding implements, and a lot of different things. A little bit about me. Started off, aside from some odd jobs here and there, the Air Force. I worked in the packing and crating section. We shipped out supplies, worked in the wood house or wood shop, did a lot of work in the solver and wood shop, and moved from there to UPS, where I worked as an application developer, worked on the website and email communication application. So a lot of just straight up development work there. From there, I went to AGCO, where it's been a mixture of development and kind of project management and overall system design, and it's not a mess, but a lot of different things. So about a year and a half, 2 years ago, we started with a project to bring a lot of our engineering teams into a kind of a global system setup, because AGCO is a company that has so far grown by acquisition. They'll buy different companies, Massey Ferguson, Gleaner, GSI, Fendt, Valtra. Those are all kind of globally situated companies. And from there, they integrate them into their setup. Some of the problems with that are that they do not start from the ground up as part of AGCO. They're all independent companies, and being independent companies, they have their ways of doing things, different cultures, different methods of basically doing stuff, as you would expect. It's not a startup where you've got 5 people and they are all kind of have the same vision and plan on doing things the same way. So, for years, since I think 1990, 1991, with the first couple acquisitions, they've been doing things their own way. And that's been an established process for a couple decades now. So not breaking them apart from those, but trying to integrate them into a global environment where the same standards, processes are followed, has been what I've been working on. So let's see here. So maybe or or maybe not, tractors, combines, those kinds of vehicles are pretty complicated nowadays. They're not just a vehicle that pulls stuff around the field. They have GPS systems in them. They have autonomous systems that can help plant crops or plant seeds. You send them out in the field, and they have swarm vehicles that we've developed that basically plant and sow a field on their own. You have air conditioning and heating in some of the cabs. That's pretty advanced. You have, let me see what else, automatic milking, automatic feeding systems, automatic morale enhancing systems for the farms. All those require software. So part of what we've been doing is trying to standardize. Is this going? There we go. Okay. So there's a couple pictures of some of the advanced looking things that we have in our fleet, in our vehicles and things that we work on and sell and have. So my group is the electronics functional group. And basically, we are in charge of kind of the overall direction of the global direction that our groups take in the software and electronics engineering group. So we manage the overall application lifecycle management, the source code traceability portion of things, just the overall way that the teams work from a software development standpoint. So like I said previously, a lot of these teams would do things independently. They would develop code, requirements, testing. That was all just kind of standalone. Site by site, they would communicate their requirements, design specifications via email, Excel spreadsheets, and that worked when they were you could walk to the next building or to a cubicle over from you and talk to your manager about this stuff. But given the direction that we've been going, trying to develop a platform strategy where the same software can run on the same machines, you have to have some sort of interconnectivity between our sites. And so you've got teams in the US, Europe, South America. Most of the engineering teams are in Europe or the US. But trying to communicate between them, new software builds being ready to test or to implement, requirements as far as what is going to be going into a new product, that's difficult. And it does seem like something that a company that's been doing business for this long should be doing by now. And they do it sometimes well, sometimes not. And that is where we are, where my group is working on. So a couple of years ago, like I said, project came to us to kind of start migrating our different sites into a global a platform, a global environment where everyone did their things, did their development, did their resource tracking, did their software development, whole life cycle in the same environment. And we needed that because as far as software builds go, a lot of the times that was someone's laptop, someone's desktop, underneath a desk that was running those builds. Once a week, once every 2 weeks, whenever a sprint cycle was done, someone would download or check out the code, run a build, publish it, and that site would have access to that build. And then maybe they would remember to send it out to other groups, and if they had dependencies, hopefully they would get what they needed to start integrating that and be able to build their software with those builds. There's multiple computers that go onto each of these machines, each of these devices, and it's a highly dependent system. There's a lot of people that depend upon something down the chain or up the chain giving something to them. Let's see. One of the goals we had with this was to kind of spread information that was known among one group but might not be known among others, such as different testing methods. So with embedded hardware, or embedded systems, which we use for vehicles, it's a little bit different than software. Like I said earlier, I came from UPS where we did software development. We had web applications, and you would have a build, you would build it, deploy it, it would go to an environment, and that was that basically. It was pretty simple. It was dependent on your application. It was a pretty standard process. Embedded systems, from what I've been able to learn so far, are a lot different and a lot more complex than web applications. One script may not be able to do what you want it to do as far as these applications. We have terminals that are built for these machines now. That the terminals are basically part of the armrest aperture that is in these machines, where there is a lot of very detailed information in there that those are. So those, depending on the sites that we had, they were doing those drastically different. So part of the first couple of, I'll get to it in a minute, but the couple of the first sites that we migrated were these terminal applications, and basically just trying to cross-pollinate these ideas as far as what were good processes with migrating and what was not, what worked, what didn't work. And also, let's see, next one. Okay, so as I mentioned earlier, we had multiple sites situated around the globe. Most of them numerically in Europe, a couple in the US. We've got some non-engineering sites in other parts of the other parts of the earth, but they don't really contribute as far as the engineering situation goes. But next slide here, we have kind of it's not an everyday situation, but some of the processes that we had would lead to this situation as far as builds would go. We'd start with team in Linnavori, Finland, having a build published to Salati, and that would go to France and Beauvais, and they would all just wait for a build to be completed and get sent, be distributed, and it was a bit of a mess. There was, it does seem like something that should have been taken care of before or done better than it was, but that's how the situation, that's how it was. It was not clean, it was not efficient. It relied a lot on manual intervention by teams. So that's what we were trying to get rid of. And yeah, it was really a mess. Some sites had independent contracts with external teams, and they would have their own setups that would work for them. But as far as the company went, that was not something that was in place as a standard. And like I said earlier, part of my team's group or my team's responsibility was to try to determine and establish a standard process that we would follow. Okay. So like I mentioned earlier, some of the issues that so some of the concerns that we had were that we were working with multiple groups, multiple cultures, multiple sites. It wasn't just one site that had a project being done. They have multiple projects. They have, anywhere between 10 and 50 engineers. I think, maybe the smallest sites we had 5 to 10. So it's a lot of people working together that it's just not what they're used to. It's like, if any of you are familiar with, Little League sports possibly, or baseball, you have an all-star team at the end of the year where you take the best kids from all the teams and all of a sudden they have to work together. You have conflicting personalities, conflicting ideas on how to work together, and they're all good independently, but trying to get them to work together is, it's an effort. And you have to convince them of the best way to do things given their new situation. And that's a lot of what we had to do here. So different sites, they had their own, like I said, processes as far as doing things. And what we were trying to do was to, if a team had a build that was done via maybe one gigantic script that had a lot of hard-coded dependencies, and that's how they did things, part of our job, or my job during this project to migrate them away from that, was to break it apart into modular pieces. We used electric flow as our continuous integration environment, and that's how we broke it apart into modules, or procedures, which would kind of help them reduce the impact that changes would make, and it would also make it so that other groups, other sites could consume those changes, or consume the kind of knowledge that they had gained from how they would complete their builds and incorporate it into their own. Because believe it or not, some teams we had, I think I forgot to mention it earlier, we would have some teams that had their homebrew setups. They would use Jenkins. They would use just a manual execution of scripts, or they would use SVN or Git, check out their code, run scripts. Talking with one of the teams recently, it was for a Linux-based build, a terminal. Every 2 weeks it would take upwards of half a day to get the environment set up for the build, check everything out, copy everything. A lot of manual steps, which that's not something we want to have. You want to be able to click a button or give a couple of predefined steps, parameters, and tell it to go. this was a lot of human interaction, which, like I said already, is something you want to avoid. So some of the earlier sites we worked with, we were kind of trying to decide which ones were different enough from other ones so that that kind of that initial foothold at those sites would be visible to the other people, and we could get them, at least able to buy into the idea that it was going to be useful to get into this global ecosystem. And so some of the biggest issues we had were trying to get them to buy into it. It was, they had existing setups that would work for them. It was how they were doing it for years. And how do you go to a team and tell them, okay, the way you're doing things, I know it works for you. I know you guys can do it. You have steps you can follow, and you know how to do it. But we need to change that and have you do the same thing, but in a different way. So there won't really be any immediate results, but that's something that you just got to do. So unfortunately for my side, I can tell that they see someone from corporate coming to tell them, this is what is going to be the new standard for you guys to follow. You guys might not see why it's going to be beneficial right now, but that's what we're going to do. And so up until somewhat recently, there's been a lot of pushback and resistance to that, but the more kind of momentum we've been getting with getting additional teams, additional sites on board with more projects, it's been going better as far as teams being receptive to getting into this ecosystem. I guess I mentioned ecosystem a bit because we've been trying to get them, a lot of the teams and sites on board as far as the whole application lifecycle management, the build, continuous integration, source control management, bunch of different things. So it's it's a whole environment really. So started off, I think probably mentioned it somewhat already, but we started off by going to a couple of pilot sites. It was a multi-phase project, but the first pilot sites were ones that were either complicated, they were diverse as far as the environment, the type of build it was, number of builds, complexity. So the first site we went to was for one of our flagship or new developments, which is a new combine, which is being developed from the ground up as far as AGCO goes. It's actually the first combine that's been developed completely in-house. All the other software builds that we had were for existing models, so this was something that actually isn't released yet, so it's been something that we've been, catching it somewhat early in the process. They've been spending the past few years defining requirements and everything for it, but the build process and builds for it have really just been ongoing for the past past year and a half, I guess, at this point now. But it's been, it was a very complex thing. That took, I'm gonna say, a couple weeks to get down fairly well. There were some unique challenges in that, given the just all the different types of applications that were used in the build. I think MATLAB caused an issue due to, what was that? Invoking MATLAB would spring up a user interface which had some issues with, I think, the electric flow agent we were using. Had to run that as a process instead of a service, just Windows issues with that. But it was, aside from that, just kind of a complex thing to do. A lot of steps involved, a lot of different variations in the build. And I don't know if I go over it later, but some of the challenges that we had were, you had people who were not super intimate with the existing build processes. They knew how to follow steps to do the build, and they had a checklist of things to do, but they could not explain it very well. They were not experts on it. So trying to migrate a build from someone's knowledge who is okay with it to get it implemented completely, that was a challenge. So from my side, having to work with these people to get their builds from a somewhat documented process to something that was, something that was working. It was a challenge, and it really just took a lot of time working with these guys to help them understand what they were trying to do and get it working in the system. So let me see. Yeah, so part of some of what we were trying to do also was, I mentioned earlier, the communication of the teams. They would send a build via email. Sometimes they had a site set up where that was really with the external teams where they would publish a build to. Part of what we set up also was a common file server for builds to be published to, so that teams that had dependencies on these builds would be notified of new changes so they could incorporate those in testing, or for their testing or for just development purposes in general. And going back to the testing portion of things, one of the things that we were able to do was, given how earlier that these builds were being done manually or kind of separate from the common environment that we had, once we incorporated these, we were able to have a common step invoked that would trigger a set of testing. So some of the testing for embedded or hardware systems is a hill system or hardware in loop, where there is, you need some complex or powerful computing machines to run these tests. And we were able to trigger these after our builds were done, and then import these or link these with our application lifecycle management system, which is Polarian that we use. So, at the end of the day, a daily build would run, and that would trigger the test run in Polarian to be executed. They would connect to Polarian, pull down all of the test cases in a test run, execute those test cases based on a testing framework that they had set up, and import the test results. So that might seem like a fairly trivial thing or a basic thing that should be done. It simply wasn't for us. So we had one of our sites, Sulati, for Valtra. They were probably they were ahead of the curve as far as that goes with our company. And given how those steps are now visible in this global system that we had, other teams, other sites were able to see that this is something that they were invoking with their builds. And Heston, Jackson, Kansas, and Minnesota, those sites, and Grubenvorst in Netherlands, they've started to incorporate that also, because they all use the same ALM system, and they're able to incorporate that same testing framework because they all use the same system now, and they're able to have their testing done automatically based on nightly builds, which is something that had not been done before. It was all manual. I can't say how much time that saved, but it's something that happens automatically now, and it's, from what I've heard, it's been a boon to their development process. It's been helpful just by having that, just by virtue of having what Sulati was doing visible to everyone else in the company as far as development goes. And then also, all those arrows pointing to the global file server, you can see that they builds are immediately available, immediately visible to the other teams. So that's just one of the other advantages of having kind of this global visible system. So didn't really, I probably touched on it a little bit, but we started off with the pilot sites by implementing a couple of the complex or different builds. Like I said, we have some of these terminal builds which are done on Linux systems, which only a couple people that do the manage the applications are familiar with. Some of the more complicated Windows builds, Windows-based builds, like that one flagship Combine build that I mentioned, those were done. So those were done in the first couple of sites. Then we moved on to additional sites. Nothing really extra there, just simply incorporating more of our engineering sites. And from there, they've been able to kind of, not evangelize, but kind of talk to the other people at those sites and get them to bring their builds into the system. Yeah, it's been a slow process getting people to buy into it, just because, like I mentioned earlier, they have something that works. Why would you want to change? It's hard to get them to buy into it, and it's taken a couple of years, really, just because of, I think, people we had working on it were me, that was about it. We worked with Electric Cloud. We had some of their professional services people working with us to help get the teams migrated and do training. But I would say if you can devote people for resources and this training, that would help getting people to buy into this kind of the setup, getting them to transition from one system to the next. But that's where we're at now. We've had additional teams at these sites come into the system. They've been approaching us, my team, to help get their builds implemented, which has been nice because we've got, I think one of the earlier slides, we had basically the number of builds per site, the number of builds that we had planned at the first migration, and then where we're at now. So some of the sites still have a lot of ways to go to be fully implemented, but it's getting better. A couple of informal surveys as far as the times that were spent compiling or setting up builds, and also forgot to mention it earlier that we had, I mentioned, builds were done via someone's local desktop, laptop. We now have dedicated infrastructure that's part of our actual network. It's a bit more powerful. Things run more quickly. So that's been something that people like. It's just basically it's process improvements that they've enjoyed so far once they get things implemented. So where we're at now, still working on getting people off of their existing setups, which is taking time, given resources on it. Training. So some of the complaints we had initially were that the way things were done before, they could kind of isolate things via Windows batch files or just scripts that were located in source control or on the servers. Getting those extracted into procedures or whatnot, it was a bit of a process. So that's what we've been working on training teams with. You have a couple of build experts at each of these sites, and they've been helping different people that work on different projects, had different projects, to get their projects implemented also. The biggest thing is the testing. The automated testing that occurs at the end of the builds is, it's not really necessary to have the build be done in this ecosystem to have the testing done, but they like just the whole thing being an automated process. So just get them in for the testing, and it kind of sets everything else up from the beginning to get them to want to start using it. And the deployment pipeline, that's something else we wanted to start working with. Given how we're not just a web application, the deployment process for embedded systems is a bit different. So we've got some other kind of projects in place for that. May or may not use our continuous integration environment, but that's something that I've been trying to figure out how to incorporate. It's an ongoing process. There's just no good way of doing it with the way our setup is. It's something I want to be able to use, but I haven't really been able to justify or find a way to get it implemented yet. So the deployment pipeline process may or may not be something we can implement in the future, but as far as testing and the actual build process, that's been something that's been working really well for us. So Yeah, and that's basically it. That's how we were able to start from no kind of shared environment to go forward to a 25% integrated environment. It's not all the way there yet, but that's where we are at. So that's it.